Saxon Advanced Mathematics, lesson 69. Today we're going to talk about a really fun way of looking at numbers called the matrix. Plural, matrices. If you have more than one matrix, you have the matrices. You may also know the word matrix as the name of a really cool movie from, I want to say, the late 1990s. Definitely ancient history from your perspective. Very cool movies. There's 3 of them. 4? I think there's 4. Starring Keanu Reeves, who you probably think of as the old guy from the John Wick movies. But he was younger here, and he was a super cool guy. And this movie's notable because it really developed some of the way that gun battles were filmed in movies that came after. It really revolutionized the way those things were filmed. So it's a little violent, but when you're ready for that, check it out. A matrix is what we call an array of numbers or symbols arranged in a rectangle. Let's write that down. And I'll show you some examples because this doesn't really help anything, right? Arranged in a rectangle. What am I talking about? Here is an example of a matrix. See how the numbers are arranged? This 3 is kind of out of place a little bit. Into rows and columns so that they make a rectangle. That's what a matrix is. Here's another example. Sometimes they have these little bracket thingies around them. All right, these are the rows and these are the columns, right? We write the name of them or refer to them, the dimensions of the matrix, by naming first the number of rows and then the number of columns. So this would be considered a 2 by 3 matrix. This would be considered a 2 by 4 matrix. In that way, they always remind me a little bit of Legos. You can also have tall matrices, 7, 3. The numbers aren't important at all for our purposes of our conversation yet. I'm just showing you the shapes of them. This would be a 4 by 2. And you could do a little cute one too. And you can do them with straight lines instead of the brackety brackets, or just leaving that off altogether. This would be a 1 by 3. All right, so they come in all shapes and sizes. What's important though is that they're filled in. You can't have like a missing element from the corner. The individual items are called entries. Okay, so that's an entry in the matrix. You can also call it an element. I guess I'm writing in the plural. So they're the entries or the elements. This is the dimension of the matrix, the individual matrix, and it is written as the number of rows times the number of columns. And 1 is perfectly acceptable. You can also have it as a single column, all right? So they come in lots of shapes and form. The ones that we're going to focus on are what we call a square matrix. So let's forget about all those other more complicated, I can't even turn my page. We can forget about those more complicated shapes. We're gonna focus on what is called a square matrix. And as you might guess, it is a 2 by 2, 2 rows by 2 columns, and when you have a square matrix, you can solve it. Whoops. It can be solved, and the answer is called the determinant. Fancy math word that just means the answer to the square matrix. Let's take a look at how you solve them, because that might surprise you. We're going to use the straight line symbol for our determinants most of the time. The only problem is it looks a little bit like an absolute value, but because it's got these numbers in this random order, you know that it's not. Here's how we solve a determinant. We start at the top on the left, and we multiply down. So we multiply 4 times 5, and then we subtract from it the bottom number times that one. Right? That's kind of weird. 20 minus 6 equals 14. So we would say that the determinant of this matrix is 14. Let's do it again with letters and develop an abstract answer that we can use as a formula. All right? If I write A, B, C, D going across in rows, which is kind of commonplace, we would do A times D minus C times B. All right, so that becomes a formula that we can use to solve any determinant. It's the same thing that we did up here. I'm just putting it into a little formula section. John has kind of a cool way of helping you memorize that pattern, and it works especially well for us who live up here in the Pacific Northwest. Here is a picture of the United States. If you don't live in the United States, I'm sorry, you just have to play along with us, or maybe you can do this with the shape of your country as well. We start up here in the Pacific Northwest. Hey, that's where I live, way up here. And we go down all the way across the country. We're going from colder weather to warmer weather down here in, it looks like Key West, by the time you get all the way down there. We're going from colder to warmer, and John interprets that as positive. That's a positive change. Then we go over here to, we're way down in Mexico, which is fine, but it's hot down here. We're starting at this corner of the country where it's hot, and we're going up toward Maine, and that's going from hotter to colder, so we see that as a negative change. But if you can remember this pattern of Seattle to Miami, San Diego to Maine, going down and then up, that will help you remember how the multiplication works. You can also just memorize the formula, whatever fits in your brain, right? Okay, so let's evaluate a few little matrices. I want a fresh piece of paper. Example 69.1. And just so you know, there are 4 examples where we're going to solve these matrices, and that's the lesson. And I also want to tell you that I'm going to copy the matrices into my problem so that we can look at it and talk about it. You don't have to do that in your homework. You can just carry forward the multiplication. I'll show you what I mean. Okay, there are no commas or anything between the numbers. As you can see, John puts a good space in between so that it's easy to read the elements. But we'd say minus 4. I'm going to use parentheses to indicate the multiplication. Minus 4 times 7 minus San Diego to Maine, 2 times minus 3. So that becomes minus 28 plus 6, which equals minus 22, and that's the right answer. That's the value of this matrix, this square matrix. That is the determinant You know, remember back in Algebra 2, we looked at part of the quadratic formula rather, and we said that that was the discriminant. Discriminant and determinant always stick in my, I trip over which one to say, but this is the determinant. Here comes another one. Copy these with me, please. Okay, we start here and multiply down. Minus 7 times 4 minus, the minus is in the formula, 3 times 5. I put parentheses around one of the numbers, but not both. Okay, so we have minus 28, minus 15. Whew, that's minus. Oh, wait. Did I copy this wrong? Yes, I did. This also has a minus. So put the minus there. So that becomes positive 28. Minus 15 is positive 13. The math on these is mind-bogglingly simple. I mean, you know, I got one wrong, but we're just multiplying and subtracting. We've got some negative numbers. Now let's make it a titch more exciting. This entry is a binomial. So this time, we don't just have 4 plain numbers. We're done with that. That was kindergarten. Now we're ready to start throwing some variables in, throwing some binomials in. I'm changing the order just because I want to have the binomial in the parentheses and I want the 4 on the outside. You can do that in multiplication. Order doesn't matter. Just remember, we're always multiplying Seattle to Miami first. Then we're subtracting, let's say LA. We've been saying San Diego, 2 times 3. But, you know, same corner of the US. Now, we distribute that out. And we see that we have oh, I'm missing one piece of the problem. I'm going to write it over here. Equals 18. Aha. So this time it's an equation. And that's going to allow us not just to simplify, but to solve for the determinant. The way I had it without the equal 18, we could simplify it, but we wouldn't get an x equals. So this changes the problem quite a bit. All right. Plus 16 minus 6 equals 10. So I'm going to subtract 10 from both sides. And I will get... Oh, I have boggled this problem in so many ways. I'm just going to keep going. It's not exactly like John's. This was supposed to be x plus 2. No, I'm fine. Okay, never mind. Subtract 10 from both sides. 4x equals 8. Divide both sides by 4, and we get x equals 2. That's the correct answer. And I did copy the problem properly. Everything's perfect. Okay, so as long as we have an equal number over here, we can solve for a variable in the entries. Oh, that's fun, right? Let's try another one. And this one, buckle in because it's going to take us for a bit of a ride. 69.4. I was trying to turn that into 64.9. Oh, this is our last problem for this lesson. Ready? Find x, John tells us. Okay. Now I keep thinking about John Wick. I don't know if you've ever seen any of those movies, but they're pretty crazy violent. And I keep thinking of John Saxon and John Wick being 2 guys at the same party. And that is just making me laugh. Okay. Let me double check. Yes. Okay, this is perfect. We see that we have an equal sign, so now we know that this is solvable. We can solve for this x. We'll just use our same strategy. But look what happens. We have x plus 4 quantity times x plus 2 quantity, right? Seattle to Miami. Oh boy. LA to Maine. It's minus, 3 times 5. And all of that equals minus 5. All right. Let's multiply this out. It's going to be x squared plus 6x plus 8. If you can multiply binomials in your head, you're always welcome to do that. In a situation like this where we have no lead coefficients, we know it's x squared, then we'll add these two to get the middle term, and we'll multiply them to get the last term. Minus 15, and then I'm going to bring this over to set that equal to 0, right? So I add 5 and bring it over. This is the minus 15 that's right there. All right, so now I have x squared plus 6x, and I'm going to combine all of this. These two come together to make minus 10. 8 minus 10 is minus 2. Equals 0. I'll leave the space here just because that's in the way. All right, this looks like something we could use the man-eating dragon on. I stop and look for a second and go, could we possibly solve this by inspection? Just looking at it, two numbers that multiply to this and add to that, and I quickly see it's not gonna fly. So let's get organized for that man-eating dragon. A is 1, B is 6, C is minus 2. Remember all this? And here's our formula. Make sure you keep this crisp in your brain. Right? You never know when you're going to be called upon to use the man-eater. So have him at the ready. In case you don't remember, I always think of the quadratic formula as the man-eating dragon, because once upon a time, a long time ago, one of my students drew an elaborate dragon on the whiteboard of the class where we had math together. And he drew this giant ball of flames coming out of the dragon's mouth. And I came in the room at that point and I was like, Zach, that's so cool. I love your dragon. What does it say? What is your dragon saying? And he got a huge smile on his face and he put this into the mouth of what the dragon was saying. It was encased in his fireball. So that's the story of why I call this the man-eating dragon, because from then on, we all referred, in that class, we all referred to it as the man-eating dragon, because that's what Zach's man-eating dragon had to say for himself. Okay, x equals minus. Now I'm making the buckets. Whenever we use, I always use buckets when A, my formula has minus signs, and B, I can potentially have minus signs in my values. It works better to use buckets. I know it takes a hot second longer, but do it. It'll always pay off. So many mistakes can be prevented if you just use buckets. All right, I always simplify what's in here first. This is going to be 36 plus 8, right? There's the positive. 4 times 2 is 8, so that equals 44. I can simplify this, because this is in the square root. I can make it 4 times 11, and I can bring out the 2, right? 4 breaks down into, the square root of 4 is 2. So here's what I'm going to have. X equals minus 6 plus or minus 2 square root of 11, right? That's square root of 44 simplified, divided by 2. And then I can factor out a 2 in each of these terms. So that'll be 2 times minus 1 plus or minus square root of 11 over 2. And then my final answer, I'm going to write up here where I have plenty of room. I'm going to take this and I'm going to cancel the 2's, and I'm going to write x equals minus 1. Oh, I'm sorry, I factored that incorrectly. I'm taking a 2 out of the 6. That should be minus 3. Sorry. minus 3 plus or minus the square root of 11, and that's the end. There is no denominator. We canceled it out completely. So this is it. And this is correct. Okay, so this is a great example of a problem where breaking down the matrix and using that technique of solving the matrix is just the first part of a bigger problem. All right? All right, that is lesson 69. I hope you feel a little bit smarter and a little bit more dangerous. And if you haven't done so already in your life, I really hope you will watch The Matrix and think of this lovely problem. All right? And if you live in a different country other than the US, I hope you will think of a cool way to use your country to come up with a similar pattern for remembering that way of solving the matrix. Okay, I'm done talking now. Goodbye.